Alright, so the third and final puzzle piece in graphing rational functions is the vertical asymptote. So the vertical asymptote is an x value that makes the denominator of the fraction equal to 0. So for our definition, I'll just write that. It's an x value, and it makes the bottom of the fraction, I'll just put a pound sign up here to represent whatever values are in the top, makes the bottom of the fraction equal to the number 0. Okay. So there are a few steps that I like to use when I find the vertical asymptote, and I always do them. It's always the same no matter what function you're looking at. First step, I just want to factor. So if I can factor the top or the bottom, I do so. Then if I have matching factors in the top and bottom, I cancel them out. And then for my final step, I set whatever is left over in the denominator equal to 0, and I solve for x. So we'll do a few examples, and we'll also incorporate our rules about horizontal asymptotes as well. That way you can get a feel for how to put it all together. Okay, so first step. First thing I'm going to do in this equation is I want to factor anything that I can factor. Let me change the color here so we can see the difference between the work. Okay, so can I factor the top? No, it remains x plus 2, so I'm just going to write it in as such. Then the bottom is a quadratic, and it turns out I can factor it. It factors into x plus 2 times x plus 1. Okay, so my next step is I'm going to cancel anything that's shared on the top and the bottom. Both the top and the bottom share this factor x plus 2, so my x plus 2 cancels out, and I'm left with a new equivalent, 1 over x plus 1. Okay, so in order to find my vertical asymptote, I take my denominator, x plus 1, and I set it equal to 0, and then I solve for x by subtracting 1 from both sides. My vertical asymptote is x minus 1. So I'm just going to draw that in. I have a vertical asymptote at x minus 1. Now let's do the horizontal asymptote. So my horizontal asymptote, I always try and determine it before I do any factoring. That's always key. So what's the degree of the top in this case? The degree of the top is 1 and the degree of the bottom is 2. That means that the top is less than the bottom. That indicates that my horizontal asymptote is equivalent to just the vertical shift. I do not have to do the ratios of the coefficients here because the degrees of the top and the bottom are not equivalent. So what's the vertical shift in this function? Well, there's nothing added or subtracted to the outside of the fraction. Therefore, my vertical shift is 0, and my horizontal asymptote has the equation y equals 0. So that's how you draw in the horizontal and vertical asymptotes. If we were to pick a few test points, my end graph would look something like that. Okay, let's do another example. So, first things first, let's do the vertical asymptote. So I want to factor anything I can factor on the top and the bottom. I can't really factor anything out of 2x, so it remains the same. But I can factor an x out of the bottom. I can rewrite it like this, x plus 3. So now I want to cancel out anything that's shared in both the top and the bottom. Well, they both share an x, so these x's are going to cancel. They're going to disappear, and I'm left with a new equivalent fraction, 2 over x plus 3. Now I take the denominator of the fraction and I set it equal to 0. X plus 3 equals 0. I solve for x. X equals negative 3. And I'll draw that in as my vertical asymptote on my graph. So that's the vertical asymptote. Now we'll go back to the original function to determine the horizontal asymptote. Okay, the degree of the top is 1 and the degree of the bottom is 2. That means that my horizontal asymptote is equivalent to my vertical shift. Do I have a vertical shift value? Anything added or subtracted outside of the fraction? No, which means my horizontal asymptote is equivalent to 0, so I can draw that in as well.